Good morning, students. In this video, I am going to continue the discussion on remaining periodic properties. Okay. In the previous video, I have already discussed about what is atomic radius and trend in atomic radius across a period and down a group, and metallic character, non-metallic character, and their variation in periodic table. I have already discussed. And today in this video, first, I'll discuss about what is ionization enthalpy or ionization potential. Ionization enthalpy or ionization potential, very important term. You have to remember the definition of this term: ionization potential or ionization energy. Okay, and it is represented by IE. Okay, so ionization, what is ionization potential? Ionization potential is the energy Ionization potential is the energy required to remove an electron from a neutral isolated gaseous atom and convert it into positively charged gaseous ion. Ionization energy is the energy required to remove an electron from a gaseous isolated atom and convert it into a positively charged gaseous ion is called ionization potential or ionization energy. Okay, so energy required to remove an electron from an atom, gaseous isolated atom. Okay, so if you want to remove one electron from the element M, then the energy required is known as ionization energy, IE. Okay, and the metal, after removing one electron, the element will be converted into cation. And mathematically, you can express ionization energy like this: M is a gaseous isolated atom, and plus I means ionization energy. You have to supply this ionization energy to remove one electron from the atom M. Okay, and unit of ionization energy is measured in electron volt per atom, and its SI unit is kilojoule per mole. Okay, ionization energy is measured in electron volt per atom, and its SI unit is kilojoule per mole. Ionization energy depends upon two factors: one is atomic size and another is nuclear charge. Ionization energy depends on two factors: one is atomic size, another is nuclear charge. How ionization energy depends on atomic size? The atomic size, the lesser the force of attraction between the nucleus and valence shell electron, and since the electrons of outermost shell lie further away from the nucleus, thus make removal easier. Okay, that means if the atomic size is large, then force of attraction between the nucleus and valence electron become weak, and therefore it become more easy to remove the valence shell electron. That is, you have to supply less energy, and ionization energy will be less if atomic size is large. Okay, and if atomic size is small, then ionization energy will be large. Now nuclear charge, greater the nuclear charge, greater is the force of attraction for the electron of the outermost shell. If nuclear charge is greater, then force of attraction between the outermost shell electron and the nucleus will be greater, and therefore electrons in the outermost shell will be more tightly held. That's why more energy will be required to remove the valence shell electron or outermost shell, that is ionization energy will be high. Okay, now see trends in ionization energy in the periodic table. Now first, across a period, the ionization energy tends to increase as one move from left to right across a period. If you move across a period from left to right, ionization energy of the elements will be increased. Okay, this is because from left to right size decreases, and if size decreases, then ionization energy will be increases. Okay, so and here the second period elements are given: lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. From left to right size decreases and ionization energy increases. Okay, in third period also, in third period, and the third period elements are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. In third period also, from left to right size, size decreases across a particular period from left to right, and as size decreases ionization energy increases. Okay, and now see, down a groove down a groove, ionization energy decreases. Okay, ionization energy decreases with an increase in atomic size, because down a groove, that is from top to bottom, if you move, you will see that size of atoms or atomic size of different elements increases. Okay, in a particular group, and as the size increases, force of attraction between the nucleus and outermost cell electron decreases. Hence it become more easy to remove the valence shell electrons. That's why down a group ionization energy decreases. Less energy will be required to remove the outermost cell electron. Okay. So there is an increase in atomic number, that is nuclear charge and atomic size down a group due to addition of extra cell, and this increase in atomic size overcome the effect of an increase in nuclear charge. Therefore, ionization energy decreases with an increase in atomic size. That is, ionization energy decreases as one move from uh, top to bottom. Okay, so ionization energy decreases as one move down a groove. Here one note is given about ionization energy. Helium, in the entire periodic table, helium will have the highest ionization energy. Helium has the highest ionization energy, while cesium of group 1 elements, at the bottom of the group 1, cesium is present, and cesium will have the lowest ionization energy. Okay, ionization energy of francium is not determined correctly as it is radioactive, so it is assumed cesium has the lowest ionization energy, and helium will have the highest ionization energy. Okay, and metals usually have low ionization energy. That's why metal can lose electron very easily, whereas non-metal have high ionization energy. Next periodic property is electron affinity. Like ionization energy, it is also very important term. Electron affinity or electron gain enthalpy, it is expressed as EA, electron gain enthalpy or electron affinity, and it is defined as the amount of energy released, just opposite of electron ionization energy. In ionization energy, electron is removed from the outermost shell, and in case of electron affinity, electron is added to an gaseous isolated atom, and the atom become negatively charged after addition of one electron. Okay, so electron affinity is the amount of electron affinity is the amount of energy released while converting a neutral gaseous isolated atom, into a negatively charged gaseous ion by addition of electron is called electron affinity. The amount of energy released while converting a neutral gaseous isolated atom into a negatively charged gaseous ion by addition of electron is called electron affinity, and it is represented like this, where X is an element, okay, and one electron is added to the element X, and the X element X become negatively charged X minus, and in this process energy is released. Okay, and unit of electron affinity unit is electron volt per atom or kilojoule per mole. And electronegativity, electron affinity is represented by negative signs because here energy is released. Okay, that is exothermic process, and exothermic, in case of exothermic process, energy release, electron affinity is exothermic process. So according to concept of thermodynamics, change in enthalpy is negative for exothermic process. Okay, here one more example is given. If you add one electron to the chlorine atom, then you will get Cl minus ion, and 349 kilojoule per mole energy will be released. Now see factors affecting electron affinity, like ionization energy. Electron affinity also depends upon two factors. One is atomic size, another is nuclear charge. Atomic size, the smaller the atomic size, greater is the electron affinity. Smaller the atomic size, greater is the electron affinity. This is because the effective nuclear force effective nuclear attractive force between the nucleus and the valence electron is greater in smaller atom, so electrons are held very tightly. Okay, so remember that smaller the atomic size, greater will be the electron affinity. Similarly, nuclear charge, greater the nuclear charge, greater will be the electron affinity. Greater the nuclear charge, greater will be the electron affinity. Okay, this is because increase in nuclear charge increases the effective attractive force on the valence electron. Now see trends in variation, the trend or variation in electron affinity in periodic table. So first see in a period, that is across a period, that is from left to right. Left to right, size decreases and electron affinity increases. Okay, so in a period that is from left to right in a horizontal rows of the periodic table, the atomic size decreases, nuclear charge increases, so electron affinity also increases. And electron affinity is highest. Electron affinity is highest. Remember this line. Electron affinity towards electron is highest for group 17 element, that is halogen elements. Halogen elements, that is fluorine, chlorine, bromine, iodine, these elements have highest electron affinity, and electron affinity is least for group 1 elements, that is alkali metals, sodium, lithium, potassium. These elements have very low electron affinity. They do not have any affinity towards electron. Okay, and down a group, down a group, size increases, and if size increases, then atomic electron affinity will be decrease. Okay, so from top to bottom moving from top to bottom in a group, the atomic size increases more than nuclear charge, thereby causing net decrease in electron affinity. So down a group, along along a particular down a group, that is from top to bottom in a particular group, the atomic size increases and electron affinity decreases. Okay, and electron affinity is maximum for group 17 element, and in group 17 element fluorine has lower electron affinity uh, compared to chlorine. Okay, and in group 16 oxygen has lower electron affinity than sulfur. So in uh, generally group 17 elements have the highest electron affinity in the entire periodic table, and down the group electron affinity is decreases. But there are some exceptional cases, like fluorine has lower electron affinity than chlorine, and oxygen has lower electron affinity than sulfur. This is because the size of fluorine atom and oxygen atom is very less. Size of fluorine atom is less than size of chlorine atom. Size of oxygen atom is less than size of sulfur atom. As a result, there are strong inter-electronic repulsion, and thus incoming electron does not feel much attraction. Okay, so electron affinity of fluorine is less than chlorine. This is due to smaller size of fluorine compared to chlorine. Next periodic property is electronegativity. Next periodic property is electronegativity. So what is electronegativity? It is also important, like electron affinity, ionization energy. It is also important. Electronegativity, it is the tendency of an atom in a molecule. It is not the term electronegativity is not valid for single gaseous isolated atom. Ionization energy and electron affinity, these two terms are applicable for neutral gaseous isolated atom, but the term electronegativity is applied for for an atom in a molecule. That is when an atom is covalently bonded with other atom, like xy. Suppose electronegativity of x is higher than y, then x will attract the bond pair, electron pair of the covalent bond toward itself. Okay, so the electronegativity is the tendency of an atom in a molecule to attract the shared pair of electron toward itself. Okay, the tendency of an atom in a molecule to attract the shared pair of electron toward itself is called electronegativity. That is, electronegativity is the tendency of attraction, tendency to attract electron present in a covalent bond. Okay, if electron negativity of x is higher than y, then x will attract the bond pair electron toward itself. Okay, and in here some points are given. Inert gases have zero electron affinity due to their stable electronic configuration. Now see, variation in electronegativity in the entire periodic table. Electronegativity also depends on two factor: atomic size, okay, and atomic size and nuclear charge. And lower the atomic size, higher is the electronegativity. And in the entire periodic table, fluorine has the maximum electronegativity. In Pauling scale, the electronegativity of fluorine is 4. Okay, this is the variation in electronegativity across a period and down a group. Okay, you can see from this table, electronegativity of different element across a period from left to right. Electronegativity increases from left to right up to group 17, and in a period, that is from top to bottom, down a group, that is from top to bottom, size increases, electronegativity decreases. Okay, so electronegativity values depends on two factors. One is atomic size, another is nuclear charge. The greater the size of an atom, lesser is the electronegativity, since the electrons being farther away from the nucleus and experience a lesser force of attraction. A nuclear charge, greater the nuclear charge, greater the electronegativity, because increase in nuclear charge causes electron attraction with greater force. Now see, trend in electronegativity, I have already told. Across a period, size decreases, so electronegativity increases from left to right. Okay, from left to right, electronegativity increases, and up to group 17, and group 17 elements has maximum electronegativity. That's why they are known as halogens, are also known as electronegative elements. Okay, and group 1 elements have very low electronegativity. And down a group size increases, so electronegativity decreases. Okay, so down a group electronegativity decreases due to increase in atomic size. Force of attraction decreases. Here some note are given. Electronegativity in case in group 1 from top to bottom, from lithium to francium, electronegativity decreases because size increases. And noble gases have complete octet. Noble gases have 8 electrons in their outermost shell. Say, that's why they do not have tendency to attract electron, and their electronegativity also zero. And note is given, generally metals show lower electronegativity as compared to non-metal. Thus, metals are electropositive. Metal can easily donate electron or release electron. However, non-metal can attract electrons more easily due to their low size. Thus, due to their small size. Thus, metals are electropositive and non-metals are electronegative. Remember that. Group 1, group 2 elements, these are metal and these are electropositive element. They can lose electron more easily. And group 15, 16, 17, these elements are, they have smaller size. Okay, and they are more electronegative elements. And now here one important point is given, diagonal relationship. What is diagonal relationship? The elements of second period show resemblance in properties with elements of the next group of third period due to very less electronegativity difference, and this leads to a diagonal relationship. That is, elements of group some elements of period 2 like lithium, beryllium, boron, this element so similar property with some elements of group with some elements of period 3, that is lithium, so resemblance with magnesium, boron, so resemblance with aluminium, beryllium shows resemblance with aluminium, boron shows resemblance or similarities with silicon, like this. Okay, so this is known as diagonal relationship. The elements of second period show resemblance in properties with the elements of next group of the third period due to very less electronegativity difference, and this is known as diagonal relationship. Here one note is given, greater the value of electron affinity, easier it is to gain electrons, and more non-metallic character or more electronegative or more oxidizing is the element. And metal lose electrons, they have less ionization potential, less electron affinity, less electronegativity metals have, and they have large atomic radii as compared to non-metal. Okay students, this chapter is completed. Thank you students.